So this is the ATX Power Supply Tester Analyser I bought a couple of months ago, something like that. And I did a review of this, and I said, oh yeah, it's great, it's easy, really useful bit of kit for testing ATX power supplies. And little did I know how wrong I was. So yeah, I mean, it is great and dead easy, and a useful bit of kit for testing power supplies, if the power supplies are working. But if the power supply, for instance, doesn't have any voltage but it has 5 volt standby, it doesn't come on. And basically after some playing around and getting completely messed up on one fault with a power supply that was actually running, that I didn't think was running, I find out that if it hasn't got the 12 volts on this connector, it won't come on. So all of the voltages can be present, can be correct, and it won't come on if there's no 12 volts. And that basically makes this thing pretty useless, to be quite honest. So I had to think about this, and I know some others commented on this as well. We need this power supply tester to come on if there's any supply voltage, whether it's just 5 volt standby or whether it's something else. 3.3, 5, 12. I thought for myself, actually, I really only need this to come on if there's 5 volt standby, because if there's no 5 volt standby, I thought, you can't have anything else. But then it did occur to me that actually may not quite be the case, because this enables the green wire that sends a signal back to start the ATX PSU by connecting the green wire to ground, and it doesn't need 5 volt standby to do that. Whereas the motherboard, yes, it does. And we know in a lot of power supplies you have like a 5 volt standby, and generated from the same little standby transformer there's often like a 16 or 24 volt supply, maybe 12 volt supply, that runs the pulse width modulator chip in the circuitry that drives the transistors. And I thought, it is possible, conceivably, you could have a faulty ATX where there's an open circuit, maybe the diode or some other open circuit on the 5 volt standby, so there's no 5 volt standby, but the 16 or 24 volts coming from the other secondary on the 5 volt standby transformer could still be there. And so I think it's conceivable you could actually have a power supply where, by connecting the green wire to ground manually, all of the voltages are present apart from 5 volt standby. So I think really the thing with this is, let's see if we can make this work here. Let's see if we can modify this thing so it will power on regardless of what voltage is there. So if it's just 5 volt standby, if it's just 3.3, it's 5, it's 12, any of the supply rails are there, and maybe not even the full rail, but a voltage is on them, this will come on. That's what you want to try and do. So I think the first thing in this case is, let's open it up and have a look to see what's inside it. So I don't think it's an overly complicated device. I mean, it's not very big to start with. There seems to be just one screw on the back of this, so let's take the screw out and see if we can actually get inside it. See if we can actually get inside this thing. So it's a long screw. Oh, okay, it came out. So does that help? Looks like these ends should clip off or something like that. So yeah, let's find a little spudger. Let's get the spudger in here, see if this. Well, yeah, I think it does. Looks like this opens up. Not easy, but it looks like this will come off. Try it from the other side. Oh yeah, I've got it. It went pop. Okay, so that comes out. Then that drops out that way. So this appears to be what we've got. To figure out which wires go where, it's probably easy just to connect an ATX power supply to it, not switched on, and then from the coloured wires we know what's going where. Okay, so I've just connected a power supply to it, and we know from previously, I'll link the video off this one, the one that caused all the trouble. That this requires the 12 volts to power up, and it looks like there's two capacitors here, and that looks like a voltage regulator or MOSFET. It says BA109 on it, yeah, BA109. Oh, let's zoom in a little bit. Okay, I don't know if you can see the part number. I think perhaps you can now. BA109 is this device. There's two capacitors here, and if that's a voltage regulator or something very much like that, then you'd expect probably one of these capacitors is on the input, and one of them connects to this leg here. You can see the track, and the other one goes to that leg and then disappears down under here. So most likely, well, one will be the input and one will be the output. So let's connect to one of the yellow wires. Yeah, let's have a look. So I'm on one of the yellow wires coming in. In fact, I can see the yellow wires. They go under here. Let's get the voltmeter where you can see it. Okay, I'll just move the camera to make it a bit easier, I think. Okay, so I've put the probe into one of the yellow wires, yeah, and we can see that pins 2 and 3, well, whatever number they are, the second and third one in are the 12 volts, yeah, which is actually this pin, yeah, I'm on continuity mode, and this pin, and that goes off under here, yeah, it goes to this capacitor. I can see it quite clearly. So this is the 12 volts coming in, and it goes round to this pin on this regulator, which I'm guessing it is. So that, I would say, it will be that must be the input, yeah. And then the output will be the other side. Yeah, let's just get hold of this. So this side will be the output, and that goes to this capacitor, yeah, and disappears under there. So it looks like this takes 12 volts coming in, because we know this runs from 12 volts, converted to some other voltage that drives this, yeah. And then the middle pin, I'm pretty much certain, will be ground. So let's take this into ground, yeah. Yeah. So we've got 12 coming in and something going out to power this up. So let's power up our PSU. We'll leave the black lead in the ground. Let's power up our power supply and have a look to see what voltage actually comes out from this thing. Yeah, I'll just go to volts mode. There we go. So power supply is on. It's powered up. Yeah. So this is going to be the 12 volts coming in. And we can see there's 12 volts, and the output will be going on this one, yeah, and it's 5 volts. So that's a 5 volt regulator, yeah. Yeah, it's a little bit warm, and that goes, and I would say that's what's powering here, yeah. So what we need to do is power this up, basically all the time, regardless of what voltage coming in here, yeah. And the easiest and cheapest way I thought to do that was to use some of these things. So I bought these off AliExpress. This came as a pack of 5 of them. You just split them off the board, yeah. Little boost regulators, and I can let's go into AliExpress and let's see what these things actually are, yeah, and how much they cost as well. Okay, so these are the ones I actually ordered, yeah, these things. They cost me €1.98 for the set of 5, yeah, so €2 plus shipping, €3.50, and I got 5 for that, so they're like 70 cents each. I thought they might just come in useful, so I thought, yeah, you must have 5 at that price. Let's just have 5, yeah, and they got some very good reviews. So this is a power supply module boost step up, output up to 28 volts, 2 amps. So basically it'll supply 2 amps. Input can be between 2 and 24, so any of our supply voltage can come in, and the maximum can be up to 28, and we can set it with a little adjustment on it, yeah. This sets the output. So basically we connect the voltage in here, and out comes there. We can set that to 12 volts and then use it to send straight into this little regulator, which will regulate it to 5, and on we go. Or we could just send out 5. Okay, right, the input voltage is from 4.5, so it won't actually run on, oh no, that's the wrong one, sorry. There's 2 devices, that's this device, forget that. The input voltage is from 2 volts, so this will run from our 3.3 or the 5. The 5 standby, the 12, yeah, this will be quite happy to run. Okay, so that's what I bought. Let's go back over and let's see what we can do with these then. Okay, so you can see these were very cheap, yeah, like 70 cents each. So what I'm thinking of doing is mounting this inside the case basically, yeah, if I can. I had looked to see if I could get it down here, and I can take this thing out, yeah, but it won't fit there. But it would fit here, but it's a bit too deep. So what I'm thinking of doing with this is to take this 5-pin Molex off. So okay, we can no longer test 5-pin Molex, but really, does that matter? Does it matter when we're testing ATX? I don't think it does. And then if I move this capacitor over here, I can now fit this board in this gap, yeah, and I can actually fit it in this way round, so the adjustment is even available from the top when this is removed, yeah. So that'll go in there. Yeah, I'll have to move the capacitor, but that's not a big deal, yeah. I mean, technically it may not even need that output capacitor, but so what I'm going to do with this, I'm going to disconnect the 12 volts. So I'm going to cut the track to the 12 volts coming down here. I'm going to leave the rest of the 12 volts as it is. I'm going to feed 12 volts into here and all the other voltages, yeah? And then the output is going to come back into the regulator, which is going to be 12 volts fixed, yeah? So I think the first thing we need to do with this is actually test one of them. So let's connect this to the bench power supply, set the output voltage, and then we can vary the input voltage and make sure it gives us a stable supply voltage, yeah? Any input from 2 to 12 or even a bit higher. Let's try it with a higher input in case one of the voltages is higher than 12, could happen, and see if we get steady output voltage. So I think the easy way to do this is going to be solder a couple of wires on here, and then we can get a crocodile clip lead from our bench power supply, and we'll solder a couple of wires on here, and again we can use some crocodile clips in the meter, and then I can adjust this without having to hold any meter probes or anything else in my hand and my fingers. So I've 2 hands free. I've got a different bit on it, by the way. I was doing something the other day, which wasn't actually, I think it was on a video, but still, not everything gets videoed. It depends on what, you know, if it's interesting. Is it interesting enough? Yeah? A little bit of flux. A little bit of flux. Okay, so this is the input voltage, yeah? We're going to connect this to our bench power supply. Okay. Just tidy that bit of wire a little bit. Bit messy, okay. It'll do the job nicely enough. So there's the input voltage, yeah, and we can connect another little bit of wire for the output voltage. This can go to the test meter, yeah. So I'll just strip a couple of wires here. That'll do for the output voltage. Okay. And just tag them on here. White can go to the negative, see if it just gets it. Yeah. And green can go to the positive. Right. That's it. So let's connect all this up now with the bench supply in the meter, get it all shot so you can see it. Now let's try it. Okay, so we're ready to try this, I think. So this is our little boost regulator, yeah. So the red and white voltage in, they go into the power supply here, yeah. I've just got them connected on these croc clips, that's why the wires look red and black go to the red and white, yeah. And the same from the test meter, they're connected to the output where the green and white are. So if we switch the power supply on, power supply is set to 5 volts at the moment, and we have 17 volts coming out of this little boost regulator. And I would guess you'll be able to alter that voltage, yeah, here. So we can set the voltage here to 12, yeah. So that little thing in here, it'll fit, yeah, okay. So let's turn the voltage here down to 12. Okay. We can get it quite accurate. A little bit more. Up a bit. Yeah, okay. That's close enough, yeah, that's close enough. So, if this is working properly now, we should be able to turn the input down to 3.3. And that should stay the same. Yeah, look, we're at 2.7 now, yeah? Let's go up. And we can go, yeah, okay, it's increasing, no, it's stabilised again. So at 12 volts, yeah? Right, then it started to rise. 12. Yeah, it seems, right, it'll only regulate up to the output voltage, okay? So if the input voltage is more than the output voltage, it can't produce lower, it can only produce more. But that's okay, because our little controller has a voltage regulator on the 12 volts anyway, which will effectively give 5 volts output even if there's too much voltage coming in. So that's okay. So that'll do what we want it to do. Okay, so what we need to do now is get it into our circuit. Yeah, so let's see how we're going to do that. Okay, so we've tested this, so let's desolder these wires from it, and we need to get this into our ATX PSU analyzer. Yeah, so we can just take the wires off. We know it's set to 12 volts, which is what we want. Okay, so I can go there. Go there. I believe it is possible to actually get other regulators that both boost and buck regulators, so they will actually allow you to produce an output voltage that's both above or below the input. Yeah, but for what we need, I'm sure this is absolutely fine. Yeah, this is fine. And it will cause no more problems than would a situation whereby you had an excessive 12 volts coming out the ATX power supply because it was faulty. Yeah. Okay, so we want to put our 12 volts in on the end of this capacitor. I'm going to put the board here. So the first thing I'm going to do now is to desolder the capacitor and this MOLEX connector. Okay, so we know we have the boost converter. Okay, this is our boost converter with a little adjustment on. Yeah, 2 ins and 2 outs. Yeah. And the output, minus and plus, yeah, so the minus just goes effectively to ground, yeah, and the same, the input just goes to ground, 0 volts, yeah. This goes to our voltage regulator, yeah. This middle pin's connected to ground, and the output of this goes to effectively like the analyzer, the electronics, yeah, inside it that does the work. Yeah, there's no doubt a little microcontroller. Yeah, so that's where that goes to, and this is the 5 volts that comes out. This is the 12 volts going in, and we set the adjustment on this to 12 volts. Now we know the input can be between 2, and it can be more than 12, but if it's more than 12 the output will be more than 12. Yeah, but our input's coming in 3.3 volts. Yeah, 5 volts, 12 volts. We'll ignore the minus 12, we're not really interested in that one. Yeah, that one I will ignore. Okay, and 5 volt standby. Yeah, and we need to connect all of these to the input of here, but we can't just connect them all together. Yeah, we can't just short all the outputs together. But there's a very, very easy way to do that, and that is quite simply to just use some diodes, 4 diodes. So from the 5 volt standby we connect a diode to here, yeah, and the same from all the other ones. Okay, we'll use 4 diodes, yeah, all connected to here. So what will happen now, basically any of these supplies will come through the diode to here. The voltage will drop a bit because the diode will drop about 0.5 of a volt. Yeah, so the 12 volts will feed about 11.5 to here, but this will step it up to 12. Yeah, the 5 volts will feed about 4.5. That will feed about 2.7, once you drop the 0.5, 0.6, 2.8, but we know this will work down to 2 volts, so that doesn't matter. We're not monitoring the voltages here. All the existing circuitry that monitors these voltages into the analyzer, yeah, going through resistors, all this will still be the same, yeah, so it will still be monitoring all these outputs this side of the diode, so the readings will be accurate, yeah, in the analyzer. So that's all we need to do for diodes. So let's have a quick look at what we can use. So I'm actually going to use some of these. I have a whole bag full of them. These are 1M4007, 1000 volt 1 amp. You might wonder why am I using the 1000 volt diodes. Well, A, because it's what I have, and B, these come in a range. So like 1N4001 is a 50 volt, 002 I think is a 100 volt, 003 is a 200 volt, and so on, yeah. But the fact is that any of those lower voltage diodes can be replaced by a 1N4007. So this one can replace all of them from 1N4001 up to 4007. So this is the only one you actually need to keep in stock, yeah. And we're going to use 4 of these, the 1 amp diodes. I doubt very much this is drawing hardly any power, certainly less than 1 amp. So we're going to put these in here, yeah. Effectively these 4 diodes with a stripe. Turn that one around, it's the wrong way around. With a stripe towards our boost converter, yeah. And then the other end of it, so that these 4 ends are going to connect together onto our boost converter, yeah. And the other ends are going to go to the various voltage supplies, and that's all we need. Then it'll work, yeah. That's the theory. So let's see if we can put it into practice, eh? Let's see what happens. So this is our little unit, yeah. The board's now glued in there. So first of all, we're going to connect. We might as well connect the output and then start putting the diodes in, yeah. So the ground goes to ground minus. There's ground all over here, so any of the grounds on here will be fine, yeah. And the other output needs to go to the input of this regulator, which is down here, yeah, which is actually the end of this capacitor. Okay, so let's get some bits of wire and start modifying this. Okay, so let's start with the easy bits first. I've got the meter on continuity, yeah. So this is ground coming in, one of the blacks, yeah, and that should go. Obviously, it goes here, yeah, and there should also be ground all over this thing, yeah, over here as well, yeah. These are all ground. They're all connected together, yeah. Certainly those ones are, yeah. So we can connect our V out negative to a ground anywhere. So it may just as well go here, yeah. Might just as well go here. So let's connect that wire first. So let's have a bit of wire and connect this one. So we want to come from V out on it, so, yeah. Negative out on the output, yeah. Let's solder. Go. Here on the V out. Just tin the wire a little bit. Then I can just shorten that just a little bit. That can go onto V out, yeah. So let's stick that on there. There we go. So this can go to any ground point on the board. We've already figured that this here is ground, so let's use that one because it's close, yeah. It's easy to get at. So a bit of a solder on the leg there. I have to just trim this little bit of wire and solder this on there. So let's just shorten the bit of wire. Okay, so I've just made the wire a bit short. I've noticed this isn't glued down very well. I possibly didn't leave the glue long enough to set, but never mind. Hopefully all the wires will hold us in place anyway. So we can just tag our bit of wire ground onto here, yeah. There we go. So that's negative out, yeah. Negative in, much the same. So we're going to take a bit of wire from the terminal here to, well, we must go to this end one because you know it's ground. You can see the black wire. So let's put that bit of wire on. Okay, so we've put that piece of wire on, yeah. So we've got both ground wires connected in and out. Now we need voltage in coming here. This is from the 12 volts coming in. But what we also need to do is, and I'll probably have to take this wire back off to do it, yeah. I need to cut the track, the 12 volts, where it comes to this capacitor. So I want to disconnect the 12 volts coming in. I want the power supply coming into here to be coming from this regulator, yeah. So let's just, now I've realised, I'll just unsolder this wire again. Yeah, let's just cut that track, yeah. So there, I'll take it off there for a moment. It's actually, we've got something in the way, yeah. Lift this capacitor up, and now I can actually cut the track just before it reaches that capacitor. Okay, so I've done that. So if you can sort of see, I've just used a soldering aid tool, this little knife thing here, to cut the track before it reaches this capacitor. The 12 volts is still going down there to this diode, but it's no longer coming to this capacitor. We can test that. We can take our meter probe and put it into the yellow wire coming in, yeah, and we should see that on the diode here we still have continuity, yeah, but on the capacitor, I'll just get where I can see, on the capacitor we don't. There's no continuity to the capacitor anymore, yeah. There. So we've cut the track there. We can lay this back down. Again, now I've laid the capacitor down, it's actually going to be, oops, glue isn't set very well. It's going to be easier to test, yeah. So the 12 volts is disconnected from there, but it's still connected to here. Okay. So we can put our wire back. In fact, you know, I'm still going to leave that wire a little bit. Other things in the way. Okay. So I'll just leave this wire off actually for a moment. It was an hour way, make life a bit easier. So we now need to take the 12 volts coming out of our boost controller back to the leg of this capacitor here, yeah. We could also solder it to the first leg of this regulator. It's probably easier going to be to get it to the capacitor. So let's put that wire on. Okay, so I've tagged it on. You can see I've just managed to I tagged the wire onto the leg of the capacitor here, yeah. We can test this, so we can go from V out here, and this should go to the voltage regulator on the right hand pin. Yes, it does, you can see it on the meter. Okay, so that's going to there. It's not shorted to ground. We can test it's not shorted to ground, yeah. And then ground should go to negative in, negative out, yeah. And the yellow wire coming in, if you just get the meter probe into the yellow wire, should no longer go to this voltage regulator because we've cut the track. Okay, so that's now connected that, yeah. So we've got the output going back to here, yeah. All we need to do now is we need to put the capacitor back on, the one we removed. So the probably easiest way is to solder it from this leg, yeah, to the tag, because that's ground and this is out, and that's probably the easiest place to put that capacitor back. Okay, so there's our capacitor soldered directly across from the output of the voltage regulator to the tab, which is ground, yeah. Negative to the tab, obviously ground. So the only thing left to do now is to put the 4 diodes from the 3.3, the 5 volt standby, the 5 volt and the 12 volt all come into the input of our little boost converter, which is here. So let's start sticking some diodes on, eh? 12 volts, well, there's 12 volts here. I'm trying to find, there's a 12 volts here on the top, yeah. That's a 12 volts, so that's an easy place to get to that. Obviously the ones on the bottom layer on the inside edge, they're more difficult. Sorry, that's 3.3 volt. This is a 12 volt, yeah, 12, 12, 12. So let's do the easy one. So we've got a 12 volts from here, yeah. So this is going to be easy. So we tag one diode onto one of the 12 volts. Let's go with this one, yeah. Bit of solder on the leg. We'll stick out with a diode on here. Again, a little bit of flux just to help it on, yeah. Find the stripe, put my diode, yeah, that way. Okay, so the first diode we can just stick here. Slipped. Okay, so that's 5 volts. Now we need to find the 3.3. There's one here at the end, an orange one, so that can go to here. Yeah, so this can be the second diode. So let's tag a diode on here as well. Okay. Again, the cathode is striped towards our little boost converter. Okay, so fell off. I thought it was on. I actually thought that was on there. I'll just check the polarity of the diode. Okay, I get a bit sold on the diode. This. I'm sorry. I'm just hard. You know, sometimes I'm working on this just to make sure I keep it in view for you. Yeah. So that's the second diode. Yeah. Just give it a second for the solder. So yeah. Okay. So that's no, not fell off again. I'll just solder this one and make sure it stays in place. Okay, so that's on there. So now we need to find 12 volts and 5 volts standby, which are all down here, but they're on the underside, which makes it a little bit difficult to solder to them. So let's see if we can find somewhere on the top side of the board that's actually connecting to them. Yeah, so let's go 12 volts first. Let's get onto one of the 12 volts. Well, we actually know where this goes. We know exactly where it goes. It goes onto this track because we just cut the track. Yeah. So if we scrape a bit of this track away here, the second one in, yeah, we can solder the 12 volts on there. So that's a handy place. Yeah. So let's just solder another diode onto here. Okay, so that's coming from the 12 volts. So we've got 3 of them now, 3.3, 5 and 12. We just need 5 volts standby. That comes in on the purple wire here, yeah. And I can see, if you look, you can see, you look at the track goes off up here somewhere and disappears through a hole. So it's the fourth one in. It goes up here, goes down this corner somewhere. And it looks like it goes to one of these resistors. So let's see where that actually goes to. Yeah. So this is the 5 volt standby. It goes to that third resistor up there, yeah. So we should be able to get our diode soldered onto the end of that resistor. I don't see any reason why we shouldn't be able to get a wire on that. Okay, let's stick another diode on there. Okay, so we've got all the diodes on here. So all we need to do basically is connect all the cathode ends of these diodes together and connect them to the input on our regulator here, yeah. And we need to stop them shorting anything. So I think the best way to do that is a bit of heat shrink sleeving. I don't need to actually shrink it. I just need to put it over the diodes, yeah, so it's long enough to cover over the legs and go over the diode itself. Why not? Just shove it just like this over there, yeah. Yeah. So I can do each one like this and solder them to this point. I'll have to extend one of these probably, but let's do it. I'll get it sorted. Let's insulate them, yeah. Okay, so there's all our diodes, yeah, all soldered down to this input on here. Okay, we can just test this now. So from each of the supplies, like orange is 3.3 to here, we should read a forward voltage drop of a diode junction. I'm on diode mode, yeah, so about 0.5. Yeah, same from if we're going to any of the 5 volts, 0.5. If we go another orange over here, just double check, yeah, 0.5. One of the yellows, just going to one of the yellows under here, 0.5, yeah, and the purple, into the purple, 0.5, yeah. And we can just check for, you know, shorts between the various supplies as well, yeah. That's just increasing. It's like a capacitor charging, yeah, capacitor charging. That's the standby, that's what I'm on. Capacitor charging, capacitor charging, yeah. So That's looking good. So just to test this now, if we take this and we connect our bench power supply and we stick, you know, a voltage into any of the voltage rails, this should come on. Yeah, that's the theory. So let's see if this actually worked. Okay, so I've connected my bench power supply. I've set it to 5.6 for the hell of it. So this is ground here. So if we go from ground and we put 5.6 volts in on the 12, you see this powers up. Yeah, let's just swing that round the other way. Yeah, so you can see it. Move that so I'm not banging my head on it all the time. Okay, so. So it's now powering up, yeah, and saying 12 volts is low, which it is, because it's only 5.6, yeah. We can go on to the 5 volt, which is here. It powers up, and saying 5 volts is 5.3, which is about what I've set it to. 3 volts would say it would be high. Yeah, saying 3 volts is high because it's 5 point something. And then the last one is going to be 5 volts standby, which is the 4th pin in along here. 1, 2, 3, 4. Interesting, it's saying 5 volts standby is low. Oh yeah, probably because it's dropping a bit of voltage through the diode. Yeah, because I'm powered up through the diode. Okay, I'm not sure about that, but it does power up with 5 volts standby. Yeah. So let's stick this onto the ATX power supply. Oh, so things moved, didn't break anything though. Stick this onto the ATX power supply. Yeah, let's just see what it does. This should power up fine with my ATX power supply. So I'll just get a mains lead and let's have a look. Okay, so I've connected the 20 way, I've connected the 8 and the 6 way as well. So let's just power it up and see what we have. Okay. For some reason it's saying 5 volt standby is low. That's the only issue we seem to have with this. Everything else is reading okay. Let's I'll get the multimeter. Let's just have a look to see. I'll just connect some cables to it. I was using them with my power supply. So let's go into voltage mode. And let's have a look to see what we got on 5 volt standby. Okay, so that goes into there, the black. 5 volt standby. There's 5.09. That's interesting. I thought I had. I mean, everything else is reading good, yeah. I don't really see why 5 volt standby is reading low, because it's connected, you know, where it was previously connected, to be quite honest. That's the yeah, that's the one I've soldered on the end of this little resistor. I wonder if I've caused a problem there. You know, I soldered the 5 volt standby at the end of the resistor, yeah. Let's have a look. Sorry about this, guys. I need to get onto it. Okay. Oh, I see what's happened now. It looks like that resistor where I connected the 5 volt standby. Yeah, one end's there. Yeah, what I've done is, what's happened is, the resistor has gone open circuit by the looks of it. So that's with me soldering to the end. I'll probably find a need to replace that, yeah. But I will do that, yeah. But I'm pretty sure this is going to be good, yeah. This is going to be good now. Yeah, so this is basically working, but we're not just getting any reading on the 5 volt standby. We're getting 0 volts on the end of the resistor. So let's have a look under the microscope and see what's actually happened here, yeah. So I think you can see actually quite clearly what has happened here. It's this resistor, the third one up, yeah, and can you see that the end has come off the resistor? Effectively, like the end cap is missing. This is the wire coming in. Even that's loose, yeah. In fact, the end cap's probably stuck to it. So that's the end of the diode, yeah. So really I just need to find a better way to feed the voltage in first for the 5 volt standby and solve this problem. These resistors marked 01C, yeah, that's actually a 10k resistor of 1% tolerance. Yeah, if you look up the 01C resistor SMD code, it'll tell you what it is. So I think the best way to fix this is going to be, let's first of all move away from the microscope, yeah, and I'll show you. Okay, yeah, so the best way to fix this, because I've got all this down here now, it's a bit fiddly to change this, but if I come from the 5 volt standby where it comes in on the board, yeah, the trackers goes off up here, and take a wire from there up over through this gap here, and I can effectively run a wire around the board and back down to this point, yeah, and solder it onto my diode. And then from where it solders to the diode, I can take a 10k resistor, just a normal, you know, not a surface mount one, just a normal through-hole resistor, and solder it to this end of here, yeah. So basically this wire coming here will connect to the resistor which goes to there, and to the diode which is here, yeah. And that should have it. I'm not sure if I've got a 1% tolerance resistors, so it might be slightly out of tolerance spec. I mean, obviously that must be fairly critical to give the exact right voltage on 5 volt standby, but I might have some 2% or something, so I'll have a look to see what I can find, and let's see if we can fix it this way, yeah. Okay, so I have a 10k resistor here. The markings are brown, black, red, brown, yeah. So brown is 1, black is 0, 0, red is 2 more zeros, and then the brown at the end will be the tolerance, which brown is 1, so that may well be a 1% resistor. But I had a look on the resistor calculator, yeah. We can go over to the desktop, and you can see actual fact that I am correct, yeah. Where's the internet? This one. Okay, so here, yeah, here you go. So brown, black, red, brown is an actual fact. Calculate 10k 1%. So that's absolutely fine to put there, and I'll have no effect whatsoever on the performance of this. Yeah. So all I need to do now is solder my bit of wire to bring the 5 volt standby round to here. Yeah, and connect the diode. And connect the resistor to the other end of this broken SMD resistor. Okay, so let me get that done. Okay, so I've now taken a wire, green for me. So you can see this is the purple wire coming in here, yeah, the 4th pin up with your standby. So we've gone from there. I've come through this gap here because nothing else is going through there, yeah. Brought it back round this little speaker, back behind here. And here I've soldered it to a resistor and the diode, and then the other end of the resistor goes to where the surface mount one was. I'll show you under the microscope, it's a little bit easier there to see what I've actually done, yeah. In fact, actually I've just zoomed down, I'm probably sure it's clearer, but so you can see the green wire comes in onto this leg of this resistor here, yeah. And that leg is then soldered to the end of the diode, yeah, so that feeds the 5 volt standby into the boost converter, and then the other end of the resistor goes down to the circuit board. Go on, let's go onto the microscope anyway, just so it's absolutely clear, yeah. There you go, now I'm sure you can see it now. So the green wire is the 5 volt standby coming in, and it's tagged to this leg of the resistor, yeah. The leg of the resistor also goes to here. This is the diode that feeds 5 volt standby to the boost converter, yeah. I'll just try and angle it up and get the focus, so you'll see that it won't short out. It's raised above the board, yeah. I mean, I could have put a bit of insulation on this, but it's not going to touch the case, and it's not going to touch anything else once this thing's put back together. Okay, then. This is where my broken surface mount resistor was, the 10k 1%, and this is a 10k 1% the same. When I came to tag the resistor on this end, so this track going under here, this feeds the 5 volt standby into the, you know, the sensing circuit, yeah. When I came to solder this, because the other end of the resistor was actually broken, the resistor came off, so that's fair enough. So that's now got around our little problem. So let's see if it actually works correctly now. Okay, so I've connected the ATX power supply again, so let's just power this on now and see what happens, yeah. So it's powered up, and you can now see that all the voltages are correct. Yeah, so we got the 12 volts, the 5 volt standby, the 3.3. It's reading the minus 12 as well. Okay, it's reading 5 volts. Yeah, everything is all there. It's good. Yeah. So that's it, guys. We've modified it, and it's now actually useful. Yeah, how about that? We've actually got a useful analyzer. And finally, there it is, all back together. Yeah. The only thing that didn't quite work is I thought where I put the boost converter in here is actually be able to adjust it. It's kind of like too far that way. You could drill a small hole there if you really wanted to, but seeing as we want that fixed at 12 volts, I don't see any reason why you'd ever want to adjust that anyway. In fact, it's probably better covered up, where you can't. So we lost the Molex connector, but okay, that's the way it was. Yeah. So yeah, that's a result. Yeah, that is a result. Okay, so let's hold it the right way up. Yeah, let's hold it the right way up. Let's put it somewhere where you can see it. Okay, so AliExpress. This is now a usable ATX power supply analyzer. As long as some voltage is coming out the power supply, be it 5 volt standby, 3.3, 5 or 12, it will come on and it will tell you. Yeah, never again will I spend 2 hours trying to repair a power supply that appeared to be completely dead because the 12 volt rail wasn't present due to an open circuit track. Everything else was there apart from the 12 volts. This said it was dead. 2 hours later, yeah, one video later, and ask everybody else, and nobody was quite sure either. We got it working. So, what's it going to cost? I mean, look, the boost regulators were 70 cents, including postage to the Canary Islands, by the way. I had a look at the diodes, yeah, 41M4007 with the postage to the Canary Islands. 100 of them were €1.35, so that's 1.35 cents each. Yeah. So to make the maths easy, let's look at 1.5 cents each. That's 6 cents for the 4 diodes, yeah, and it is 70 cents for the boost converter, yeah. And that's me just buying them in small quantities and getting them shipped from China, yeah. So I think you guys, you could even modify this PCB, yeah, so that the boost regulator is on the board. That'll save you the cost of the other little PCB. It's just the components. So I believe you can make these for what, 50 cents more on the retail price, and actually make a bit more profit at that. And it's a useful bit of kit that people can use to repair ATX power supplies that are faulty. Yeah, I mean, come on, how difficult is it? Yeah. So there you have it. I'm happy with this now. I'm sure other people on this channel will be happy with it, and I hope other people will modify their piece of crap analyzer to actually be useful. Yeah. So there you go. I'd like to see these made. Any royalties or commission, gladly accepted, I will add, by the way. So remember where you saw it first. Yeah, Richard, learn electronics repair. Now learn how to build bits of kit properly. Okay, see you all soon, guys. That's been my favourite video for quite a while. Ciao for now.